Hello everyone. In today's video we are going to study little more about how to write chemical formulas, how we write the valencies, all these things. So just before starting our next topic, let us revise what we studied in the previous video. We studied about what is a radical, isn't it? In the last video we studied about what is a radical. What is a radical? Radical is an atom or a group of atoms, isn't it? Radical is an atom or group of atoms of the same or of different elements that behave as a single unit, isn't it? They may be formed of a single atom or a group of atoms of the same element with a positive or negative charge. They behave as a single unit. That is what is radical. Now here we are going to see what is an electropositive and an electronegative radical. So before going to that, here there is a note about what happens when an acid reacts with a base. In the example given here, we know that hydrochloric acid is a strong acid, isn't it? And potassium hydroxide is a strong base also. When an acid reacts with a base, the product that we get is known as the salt. So what is the salt we get here? Potassium chloride. So when an acid reacts with the base, the product we get is a salt and water. And what will be the nature of this salt? Will it be acidic or basic? Please remember, this reaction between an acid and a base is known as neutralization reaction. Neutral means what? The product that we obtain when an acid reacts with base is neither acidic nor basic. It is neutral. Okay, that is why this reaction is known as neutralization reaction. So we get a neutral product called potassium chloride. And here potassium hydroxide, the base, and hydrochloric acid is the acidic part. Now we have got this potassium chloride, KCl. Potassium chloride, its formula is KCl. When we dissolve this KCl in water, what happens is it will split. Okay, it will split into its constituent elements. It will split into its constituent elements. Okay, it will split into its constituent elements, potassium and chloride. Okay, it will split into its constituent elements, potassium and chloride. Okay, and it will have charges also, K plus and Cl minus. K plus and Cl minus. When we dissolve this salt in water, it will split into its constituent radicals, K plus and Cl minus. We know that potassium is obtained from potassium hydroxide, the base, and chlorine is obtained from the acidic part, hydrochloric acid, isn't it? And potassium have a plus charge above it, and chlorine has negative charge above it. So these radicals K plus and Cl minus have their names. K plus, which have plus sign on it, is known as the electropositive radical. Electropositive radical. And positive, this is also an ion, isn't it? K plus charge is there, it's an ion. So electropositive radical, or it is the cation. It is the cation. I have already told you an easy way to remember the charges. Positive charge is cation, Pc. So electropositive radical, which one is the electropositive radical? K plus is the electropositive radical. It is also known as the cation, and the easy way to remember this, positive charge, cation. And Cl minus is known as the electronegative radical. Electronegative radical. And what will be its name? It has a negative charge. What do we call an ion with a negative charge? It is known as the anion. It is known as the anion, and short form not applicable. We already studied it, Na. isn't it? Not applicable. Here we use N for negative and A for anion. Negatively charged is anion. Okay, hope it is clear. Radicals, electropositive radical and electronegative radical. Okay, now in this page we are seeing different tables. First table, table 1.3, it shows some electrovalent positive ions which we get from basic, which is a basic radical, isn't it? It is a basic radical. So first we see some of the monovalent. Mono means what? One. Valent, valency. So monovalent electropositive ammonia. First one is ammonia. Its formula is NH4, isn't it? Its formula is NH4. So ammonia, you can see only positive sign is there, plus sign, only one plus sign is there, no other number, so it is monovalent. Second one is gold, Aurus. Second one is gold. Third one is silver, Argentus, and cuprous, Cu plus. All those have only plus charge. It means plus 1 plus. We don't put 1 here. You should remember it has a valency of 1. Divalent electropositive. What do you mean by di? Di means 2. Silver, argentic, 2 plus, barium, Ba2 plus. Here you can see that silver shows 2 valency, isn't it? As silver 2 and silver 1. If it is 1, argentus, and if it is 2, argentic. In last video I have told you about this cuprous, cupric, everything. Then barium, Ba2 plus, Ba2 plus. Then calcium, Ca2 plus, cupric, Cu2 plus. Trivalent, tri means 3. Aluminium shows Al3 plus. Then arsenic, As3 plus. Auric or gold, Au3 plus. Again gold is showing one more valency. Bismuth, Bi3 plus. Tetravalent more than 3, that is 4. When the valence is 4. Plumbic or lead, platinic, Pt4 plus, tannic, Sn4 plus. So these are some of the basic radicals. Now let us come down to list of some common electrovalent negative ions. Negative ions or acid radicals. Acetate, CH3, COO minus. Here the one is not written. It is understood that it has a valency of 1. Bicarbonate or hydrogen carbonate, HCO3 minus, hydrogen sulfide, bismuth or bisulfate or hydrogen sulfate. Then here divalent electronegative, CrO3 2 minus, dichromate, Cr2O7 2 minus. Here this 2 minus shows it has a valency of 2. Trivalent where the valency is 3 minus. Arsenate, nitride, aluminate, arsenite, all these are examples of trivalent electronegative radicals. Tetravalent, tetra means 4. Carbide, C4 minus, ferrocyanide, Cn6 4 minus. So just for an idea, okay, for example you should just go through it and remember. Okay, now an important part, how to write the chemical formula of the compounds. There are certain steps to be followed when we are writing the chemical formula. You should know the valency of some common elements. You should know it, okay. You should know it by reading and reading. If you by heart it, sometimes you may forget, but understand, think and use it. So let us see how we can write the chemical formula of compounds. For that, what we have to do, let us see. First let me write an example here. Magnesium is Mg and chlorine Cl. Magnesium and chlorine. The valency of magnesium is 2, Mg 2 plus, and valency of chlorine is 1 minus. When these two compounds combine together, we will get magnesium chloride. We get magnesium chloride. But how to write the chemical formula? What we do is we interchange. Interchange means the valency of chlorine will go to magnesium and the valency of magnesium will go to chlorine. So we will write like this: magnesium, whose valency come here? The valency of chlorine will come here. It will be like this: Mg1 and Cl2, like this. The valency of chlorine is 1 minus. We don't write 1 here. For example, I will write here. This 1 will go just below magnesium, and the valency of magnesium will go below chlorine. And what is the formula of magnesium chloride? We don't write Mg1Cl2. Its formula is MgCl2, magnesium chloride. Okay, magnesium chloride. And this way of writing the formula is known as crisscross method. Why it's crisscross? Because we are writing crossing X, isn't it? So interchanging valency. This method is known as crisscross method. Crisscross method. Here we interchange the valency of the elements and write the products. Okay, that is the first step that is written here. Write the symbol of the elements side by side. And another important thing we have to take care is, first we have to write the basic radical followed by the acidic radical. That is, first plus sign. Basic radical is always positive, that we have to write first, and then write the negative radical, okay, or acidic radical we have to write second. Then we wrote the valency of the elements above it. After that we interchange the valency and write the product here. Is it clear till here? Oh, hope you are clear with this. Okay, now I am writing a different example of calcium and oxygen. They react to form calcium oxide. The formula of calcium oxide is CaO. We know that the valency of calcium is 2 plus and valency of oxygen is 2 minus. If the valency of calcium is 2 and oxygen's valency is 2, then why it is CaO? We have not written Ca2O2. Why it is there? If they have the same valency, we know that we divide both of them, and if they have the same valency, we don't write them together, we divide it, or we find the highest common factor. The highest common factor here, both are 2, so 2 divided by 2 is 1. Here also 2 divided by 2 is 1, or we just cancel it out. It is easy to remember that if there is plus, if there is minus, we just cancel it out and write the formula as CaO. Okay, both the numbers are same. We don't write the valency Ca2O2. We just cancel it out and write CaO only, calcium oxide. Okay, calcium oxide. And I'll write another important thing. Okay, and the important thing where you have to find the HCF of the two compounds and then write their chemical formula. Let us see. For example, I am not writing the name of any real compound. I am giving it as X2 and Y4. X2, Y4. First, what we have to do? Interchange the valencies. So what happens? If these two elements react together, we will get X4Y2. X4Y2. In fractions, in maths you have studied that always we have to keep the fraction in its lowest term. Similarly, if we are writing the chemical formula, if there is a common factor in these valencies, we have to divide these two. We have to divide these two and bring it to its simplest form. That is what is given here in this third step. Okay, divide the valency numbers by the highest common factor, then bring it to the simple ratio or to the lowest form. Here we know that 4 and 2 are the multiples of 2. So what we have to do? We have to divide 4 by 2 and y 2 divided by 2. What will we get? 4 divided by 2 is 2. X2, 2 divided by 2 is 1. What's our formula? X2y. We won't write x4 y2. If there is a common factor in these two valencies, divide them with their common factor, highest common factor, and the result is our answer. Okay, this is how you have to write the chemical formula. Okay, hope is it clear? Please study this, is very important. This is ABCD of chemistry, knowing to write the chemical formulae. Okay, then in the next part we are going to study how we can name certain compounds, how we name a metal and a non-metal, if there are two non-metals together, if two elements and oxygen, all these things we will just study now. When we are writing the name of a metal and a non-metal, for example, calcium and nitrogen. Calcium is a metal and nitrogen is a non-metal. If a metal and non-metal reacts, how we can write its chemical formula, or how we write their names? And the product that we get here is called calcium nitride. Calcium nitride, that is the product that we get here, calcium nitride. And how we name this product, how we got the name calcium nitride, that you have to understand. Calcium is a metal and nitrogen is a non-metal. When a metal and a non-metal reacts, first we have to write the name of the metal followed by the non-metal, and the non-metal should end with the suffix IDE. Should end with the suffix IDE. We will not write calcium nitrogen, but instead of OGEN, what will we replace? We will replace with the suffix IDE. First we have to write the name of the metal followed by the name of the non-metal, but the name of the non-metal should end with the suffix IDE. That is why we have written here calcium plus nitrogen will give calcium nitride. That is the first thing. Second, if two non-metals are reacting, together, what happens? For example, phosphorus is a non-metal. If phosphorus reacts with chlorine, chlorine is another non-metal. Chlorine is a non-metal. We get a compound called phosphorus trichloride, PCl3, phosphorus trichloride. We know that valency of phosphorus is 3, valency of chlorine is 1, interchange we get PCl3, phosphorus chloride. Okay, phosphorus trichloride, 3 chlorine are there. So if two non-metals are reacting together, what we have to do is we have to write or prefix tri, tetra or penta, depending on the number of the non-metal in the second part. Okay, after the name of the second non-metal, we have to write their name depending on the number of atoms of that second non-metal is present. PCl3, phosphorus trichloride, that means 3 chlorine atoms are there. If there is phosphorus pentachloride, PCl5, here phosphorus, name of the first non-metal, followed by name of the second non-metal, but before that we have to add the suffix according to what is the valency of it. PCl5, it is phosphorus pentachloride. Phosphorus pentachloride. Okay, pentachloride. Same thing, some important terms that you have to remember is shown here. If the number of oxygen, when the number of oxygen, for example Na, sodium hypochlorite, if the number of oxygen is less than 2, we use this prefix hypo, NaClO. Number of oxygen is less than 2, so we will write its name as sodium hypochlorite, RITE, hypo, HYPO, hypochlorite. Okay, now another example, NaClO2. Here the number of oxygen atom is equal to 2. If the number of oxygen atoms is equal to 2, we use the suffix ATE, and the name of this compound is sodium chlorate. Sodium chlorate.